porosity in them than do tight limestones. And since these things have more porosity, you can see the porosity in them. You can see all there's intercrystalline porosity. You can see all the little spaces, the little holes in there. That means the rocks can be more easily invaded by groundwater. And that's why this formation is so strongly and easily weathered. If you drive along by a highway cut of this stuff, it's brown. It's not gray or white like a limestone is. It's brown because there's a little bit of pyrite in there, and that's weathered in the modern day weathering regime.
So all of the first outcrops we saw coming north around north of Rockford,
yeah.
they were galena as well?
Yes, right.
Okay.
Yeah. That's galena as well. And then you didn't see much rock for a while.
Right.
Yeah, because of you came across the terminal moraine at Janesville. And
okay. So is there a thin veneer of glacial here?
We're just into the driftless
area.
Into
the driftless
the terminal moraines at Verona. So we've just come out of the glaciated area here. And you went up onto that big rise. Lloyd Pray used to call this Sinope Mesa. He's a southwestern type. So he said, we've got this big mesa of galena that's forming the surface of the land. The erosion has removed everything above it. Excuse me, but it's a 200-foot thick dolomite, and it tends to hold up the landscape. Okay, and so when we get back out on the highway and we're driving to our next stop, you can look around and see for a long
I didn't
distance.
see any outcrops, so I thinking it looked like, I thought it was glacier.
You're sitting right on top of this erosional remnant right here. Once upon a time, there used to be Silurian rocks overlying, and probably Devonian rocks overlying as well, and all that's been removed by Cenozoic erosion. It's worked its way down to this big, thick cap of dolomite. Okay, what do you got? Is this dolomite? No, this is chert. This will scratch steel. You can prove it on your hammer there. It has a conchoidal fracture. You can't see any grains in it. It's cryptocrystalline silica. This is chert. And the chert in the galena is formed in layers. You can see it quite clearly on that. See that fin of rock that's sticking out over there? Well, on the weathered surface. See those layers, those white layers over in there? These are chert layers that formed in the sediment after deposition. Sometime after deposition. Somehow or other, silica-bearing fluids move through the rock and preferentially crystallized, or nucleated I should say, it's cryptocrystal, nucleated and grew within the sediment to form little nodules. Why the chert is localized in particular bands is not known. I would love it if someone would figure this out. You can use the fact that it is there to say, well, that's the Eagle Point member, because the chert's always there. But why the chert was formed there in the first place, we don't know. And what the source of the silica was, we don't really know either. Oh, and I stole it from her. I stole it from you. Who did I steal it from?
What is I've never heard of cert forming.
The circular stuff. I think this is all...
Dude knows what he's talking about. I don't know.
I'm saying, this looks new for me.
Yeah, me too.
Chert is always so associated with deep water.
Little bits of silica, little nodules of silica that then were encased in a larger nodule. So you have several different things all encased in this one. I think that's what this is. It's very difficult to say. So both the dolomite and the chert are secondary features. They're not part of the depositional system. They happen to the rock after it was buried, and they involve fluids moving through this rock at some later time.
I wonder if they could be at all genetically related to geodes, because we get these geodes in the limestone south of Indianapolis, and we're at the Borden area.
Yeah.
So you know, they're silica, of course,
Right.
nodules
Right.
deposited in limestone.
But why they're localized
Yeah,
there?
I don't know.
Yeah, I don't either. Here's some more.
What's this one? Oh, we just. Amy got one of those.
This stuff. Is that what you're looking at? Oh, this stuff. I think that's just unweathered chert.
Oh,
That the weathered chert has turned white and the gray is more fresh. I think that's what it is. You can see on the weathered surface over there how it's very white, and there's a whole raft of it. That's the Eagle Point member starting right there. Okay, so what happened to these rocks? They were deposited. They were lithified. We're back 450 million years ago in Ordovician time. There are a couple of possible sources for the fluids that move through these rocks. One of them is that they could be meteoric fluids from the weathering zone. In order to do that, then you have to have a sea level drawdown. You have to expose this area to rainwater, and then you got to flush the rocks through with more or less fresh water. But the ionic composition of the fresh water is not the same as the ionic composition of seawater, and it's possible to imagine that fresh water is carrying the magnesium ions that will eventually turn the rock into dolomite. People have modeled this. People have shown that it works chemically. So one way of making dolomite is to flood it with fresh water on the surface.
I was just told the opposite. Stop.
Right.
Is that not viable
There's
anymore?
another one that's
Oh, it is possible. Oh, I
Yeah,
see.
that's certainly
I
possible.
hadn't thought about
But
the freshwater.
My particular bias is that I see no evidence of sabkas anywhere in these rocks. There's never a stromatolite in here. Never. There's nothing that would indicate hypersalinity. There's no sand.
Aren't there little salt bugs in here?
Well, Dave Delgado said he could see salt bugs.
Uh-huh.
I'm not convinced.
Oh, really?
In fact.
Because I thought when we scouted it out, I thought I found some good answers.
Show me there. But the sort of things that you see in a sabka, you don't really see in this galena, I think. So the idea that it could be fresh water is certainly a possibility. The other big fluid loss that we're sure happened was in late Paleozoic time, and that's fluids coming out of the Illinois Basin, the mineralizing fluids that created the lead-zinc district in southwestern Wisconsin, the mining district. We know that these rocks were flooded with hot fluids that were carrying the ore in solution. If you go a few miles southwest, you are into the mining district where you can actually see the sulfide minerals that were precipitated in this galena formation.
Why is this called galena then?
That's why it's called galena.
Because it's very, I keep on having little ticks. It's not galena. Okay.
Yeah. It's named after Galena, Illinois,
Okay.
where it is exposed. Galena, Illinois is called Galena, Illinois because it's in the mining district. Yeah. So we're mining lead. These rocks then had to have been flooded with hot fluids coming out of the Illinois Basin, and perhaps that's part of the dolomite history as well. In fact, it could have been multiple.
So we have fresh water, salt water,
Or
and
basinal water. Yeah.
so is it possible to have some sort of ionic gradient? Because we had salty water which has a different ionic composition, and we had fresh water which has different ionic. So is it possible to have some deposition because we have gradient change between the salty water and the fresh water?
Right along that boundary.
Uh-huh.
Yeah, it would. I would think it would be possible. The thing that strikes me is that the whole 200 feet of the rock is all dolomite all the way through here. And so if you were going to call on that little gradient to be your mineralizing zone, then how are you going to get it to move up and down? If you follow this formation to the southwest and over into the state of Iowa, you're going into what was probably a deeper basinal environment at that time and had its head out of the water less frequently. Here we're on the edge of the Wisconsin Dome. Chances are it saw more fresh water. It's limestone over in Iowa, at least in part. It's all dolomite up here. And so that sort of argues for the freshwater model, in my humble opinion. I try to think about dolomite as infrequently as possible. But some people are just fascinated by it.
So what are they mining in this quarry?
They are taking, the underlying formations are the Decorah and the Platteville. They're taking all of this carbonate out and crushing it for gravel. This is used for road gravel all around southern Wisconsin. So they're just, you can see it would make a horrible building stone.
Yeah.
It's so buggy, it's so crumbly, it has no strength at all. The only thing you can do for a minute is crush it up, and it doesn't take too much force to do that either. So there's a lot of little farm land quarries, you'll see a little bite out of a hill, and a farmer can crush up his road gravel that way.
Mandy did find some galena.
Oh yeah.
So I didn't listen to him talk, but I figured it out.
Hey, cool. There you go. We're in the mining
This
district.
is galena here.
Yeah.
Galena is a lead sulfide ore. That's how.
Stake a claim.
That's how Wisconsin got its nickname, the Badger State, because the miners would burrow into the rocks like little badgers. So,
Right. And if you look at the state seal of Wisconsin, it shows a sailor and a miner, and the miner is standing beside a pyramid of lead bars. There are 13 big chunks of lead. Basically, we wouldn't have been a state if it hadn't been for the lead zinc district. We wouldn't have been a state nearly so early because people wouldn't have come flooding in here if it hadn't been for the mining district. Okay, you guys have other questions? I want to show you a couple of features here. Let's see if I can find a piece.